Good morning, everyone. Welcome to JIC. I'll just open up my mask. Okay, so you guys are welcome to open if you are comfortable. If you don't want to, it's fine as well. So good to have students finally back on campus because for the last 2 years it has been a very difficult time for the students and for teachers as well. Just very quickly, I'll introduce myself. My name is Junaid, Junaid. In Indonesia, I think they call it Junaidi, but I'm without I. Okay, so and I'm very happy with the name that my parents have given me. So normally that is what I tell the students that use this name. And if you want to contact me, you guys can contact me at Junaid.Rana@jic.ac.id. So that's my email address. You guys are more than welcome to drop me an email if you're interested. About my qualification, I have, of course, a bachelor's in commerce. Then I have a master's in computer science. I have a master's in business economics. And then I have a PhD. Okay. So my PhD is also in the field of management. I completed my master's in the year 2000. PhD I completed in the year 2017, and this PhD was with a GPA of 3.91. With a summa cum laude, so I got a gold medal as well. So that's my qualification. And I've been here in JIC since 2003. So I've been here with JIC for a long period of time. I had different roles here in JIC. So I have worked as a part-timer, started off as a part-time teacher. Then I became the full-timer, and eventually 2007 until 2019. I was the vice academic director. So I was managing the academic affairs throughout here in JIC. And then since 2019 until now, I'm heading our research department. Ever since I completed my PhD, so now I'm heading our research department. So we have a research department where we conduct research, where we conduct certain trainings for the students, for the teachers. So that is what my job description is all about. Any idea which country I am from? No idea. Okay, I'm actually from Pakistan. I'm actually basically from Pakistan. But now I'm here in Indonesia. I've been in Indonesia since 2002. And now I'm an Indonesian, officially an Indonesian citizen already. So the topic that I've chosen for us to, thank you. So do we have students online as well? Yes. You already joined us. Okay, so we have, can they see me on this channel? Yes. All right, okay. So, all right, guys online as well. Welcome to JIC. I hope all this time you guys were hearing me. So that's another issue that we have when we come across hybrid classes. So, but anyway, let's get started, guys. Yep. So this is working. So basically, there are many things that I can discuss with you guys in today's class, but this is the topic. It's a very basic topic from one of our part of the class for the context of information technology, in which we will cover modern computing and information technology. Okay. So if you guys have any questions, the students who are online, you guys can ask us the question, or you guys can drop a chat message. We have a staff here, and she will address your questions to me, right? Yeah. Yes, that's okay. Thank you. So thank you for your assistance, and thank you guys who are here taking the time on a weekend to come here and join us for the session. So in today's topic, this is actually how we conduct the classes. So in today's topic, we're going to talk about the systems and information systems. Can you just check with the students there? They can see my screen, right? Okay. Yeah, please. So we will talk about what systems are and what is an information system. Then we'll talk about people, hardware, software, what are procedures, data, information, and what is the difference between data and information. It's a very basic topic. Maybe some of you guys have studied this in your previous schools or high schools, that's fine. But the main idea in today's class is actually to show you how we conduct the classes here. So why learning about computers is important? Because computers are common tools in all the areas of life. Everywhere we use computer systems. Okay? Systems are everywhere. Now even our computer systems are in our mobile phones as well. We have computer systems in our equipments, daily equipments that we use. Refrigerators have information system. They also have a computer system built in them. The cars are coming up with an information system within them as well, built within them. We have in JIC, we have our own management information system, also known as MIS, Management Information System. Because new forms of learning and working have developed because of the computers. We have distance learning. We have already experienced that. We have online course instructions, home business opportunities, where we have seen how Gojek and Grab has actually, it's a very good example of the systems where Gojek and Grab does not own any of the resources, like the drivers, they don't own them. The restaurants, they don't own them. The motorbikes, they don't own them. So it's just a platform where users and the sellers, they interact. Okay, so it's more of like an economics. So they're provided them with a point where they can interact. We order a ride, just like a taxi. And just for your information, when Gojek started its application, they went over to Bluebird Taxi Broker's to find investments. And at that time, they only did 2% of the investments in Gojek. And when that happened, eventually what happened was that Gojek actually grew so big and they started threatening the market for Bluebird as well, right? Because there were taxis, we can order cars online, the customers, they can come, so they were much cheaper compared to the Bluebird taxis. And now, the Bluebird taxis, Gojek owns 20% of the shares in Bluebird. So this is what can happen when you grow up in your system. So you guys who are millennials, most of the researches that have been conducted in the past have shown that millennials are more into businesses. I don't know how many of you are interested in business, in setting up your own business, guys. Nobody? You want to do a job? Yeah, not sure, fine. But there are ideas that you can float. Some very smart ideas. Facebook ideas, Instagram, even the Microsoft, Apple. All of this was started by students. That is exactly what you guys can come up with as well. So because we need ways to communicate, to find people with similar interests, and to buy goods are available because of the computers. So again, it is all because of computing. I have seen that era of computing in 1980s. I remember my uncle was doing a business of computers. At that time, computers were very, very expensive. And they were just like the desk, the monitors were this high, they were this big, the CPUs were very small. There was no Windows. It was disk operating system, DOS. So we had to enter instructions in order to run that particular computer. I remember at that time I was very young. I was just like 8 years, 7 years. So we used to go and play games on the computer. It was very fascinating to play games in that era. Then came Windows 3.4. I still remember that. As soon as we transitioned from DOS towards Windows operating system, it was very difficult for us to adapt. From there, then they came over to Windows 95. That was much better. Then came Windows 98. Then came Windows 2000. And then in the year 2000, above, they came with Windows XP. And then came Windows 7, Windows 8, and then finally Windows 10, and now we've got Windows 11. So all of these over the years, it has been a very fast transition of computer systems. Computers over the years have become actually very smaller. In the past, these computers, yes, Mr. Okay. In the past, the computers were actually as big as this room. No, the computers were as big as this room. Because initially the computers were actually used by the American military in the Second World War. And then over the years, after the Second World War, they passed it on to the universities to conduct certain researches. And that is where once it came, universities started to researches, the transistors and other equipments of the computer started becoming smaller and smaller and smaller. I'll quote to you in 1998, me and my brother, we bought our first computer, a desktop computer. I'll share some specifications with you guys. The RAM was the best RAM available at that time. And by the way, that computer cost us $1,000 at that time. So the specifications are just very limited specification I'll share with you guys. The RAM was 8 megabytes. The hard disk was the biggest available at that time was 2 gigabytes. And the processor was, I think it was Intel Core i2, something like that. And it was like $1,000 worth of computer. Now, even if we had that computer today, I would give it to somebody for free as well, a person would not want it. Because it's obsolete, it's gone. Right? All of these laptops that we use these days in the next 5 years, we cannot even use them. I had another computer which used a hard disk. It was not, it has gone very slow. And now when I open it up, it's like, what's happening with this computer? And we've gone through that computer. I still have my first USB that I bought in the year 2004. And I was so happy because previously, do you know floppy disks? Right? So floppy disks were, in the past, they were 1.4 MB megabytes. 1.4 MB. We can't even store anything over there. Most of the time, they used to get corrupt as well. So then they came out with the USBs. And I was so happy to buy that. It was very expensive. I think it was just 256 megabytes USB. That was a huge improvement. And these days, we have got 1 gigabyte USBs as well. We have got 1 gigabyte small SD cards. A lot of information can now be stored on very small devices. So that is how computers actually have evolved. So we have got Ethernet, emails, we've got news groups, chat lines, e-commerce, and so on. So let's first look at how the systems were evolved, because eventually, ever since the computer has evolved, computers have come up with many fast processing speeds. Of course, that is where we then started the need of a particular system. It's a set of components that work together to achieve a common goal. So that is what a system is, right? A system can be anything. Like here, we have a certain system here in JIC. Right? All of you guys have followed a certain system in order to come and enroll in this session. So clearly, there are a set of components, there are certain parts that you need to achieve or accomplish before you can sit into these classes. That works together. You have to do the enrollment, you have to set up a time, you have to pick up what subject would you like to enroll in, IT, for example, to achieve a common goal. So the common goal that we have is for you guys to learn, for us to teach. So every system also has a subsystem. A subsystem is one part of the system where the products of more than one system are combined to achieve an ultimate goal. So a subsystem is a part of a super system, right? So we have a subsystem, a smaller system, for example, a library information system. For example, management information system. For example, financial information or finance information system. A marketing information system. So that is all of these systems, they constitute a subsystem. And when we integrate, we join all of these systems together,
we get an MIS, Management Information System. Because I need to know which student has enrolled academic information system. Did that student pay the fee already? I will get that information through the finance information system or accounting information, whatever information system we follow. And then if I want to know if you guys have got your books or not, I will connect with the library information system. Right, so we can see that all of these systems, they work together. Not just here in JIC, but also if you look at online shopping, if you go to, for example, Weebly, JD, Tokopedia, whatever the platform that you use, that is also made up of many subsystems. Of course, when we do a transaction, we buy a certain good, then eventually what happens? We are connected to a banking information system, right? Where we do the payments for the transaction that we do. Then there is also a subsystem of the delivery process, right? Either through Gojek, Grab, JNE, whatever the services that are available. So we go through those systems as well, right? And same is the case with the traffic information system. You know, there are different lights, then they have those cameras, they are connected with the fines and the penalties that you need to pay if you, for example, violate the law. So there are different information systems. Anybody who can think of any other information system? Anyone? Come on, guys. There's no right and wrong answers. Okay? So I want you guys to participate. It's not just a one-way traffic. Let's make it more interactive, especially when you guys are here. Do we have some prizes for the students? Some chocolates?
In front.
Okay, in front. Right. Yes. YouTube. Okay, that's very good. How do you see that as a system and a subsystem?
Yes, like the front end and the back end. I guess the one who's going in the back end, that the servers can transmit the video to the device. And there's also the front end for the design of the, like, how do you do? What type of
Will work, okay, that's very good. Yes, excellent, good example. So YouTube is also one of the systems, and then there are subsystems in it. Like recently, they have introduced some short videos, right? So that itself is a subsystem inside a bigger system. They have integrated advertisements in the videos, right? So they have integrated subscription plans. They have integrated some payment plans, right, which works through, which has different components, different parts that work together to achieve a common goal, right? So everything around us, not just computers, in our day-to-day life, we do interact with systems. For example, planning to come to JIC, you have to follow a certain system. Right? Now that's more on the management side, which is planning, controlling, organizing, leading. That's exactly what we need in a system as well. We need a plan. What are we going to do? Yes, we are going to upload videos. How are we going to do it? That's organizing. What if something goes wrong? We have to control the things. Right? So that's the management side. Because I teach both, as I said, my qualification here is on the management and on the computer side. So that's where actually whenever I teach, I try to integrate these subjects so you guys have more broader perspective of learning. Right. So we also have certain systems which are closed systems. These are standalone systems that have no contact with some other systems. Right? So they have no contact with other systems at all. For example, like ATM machines, they are just going to be a user interface. That is our information, and at the back there is the banking information system. Nothing else is there. That is a closed system. Then we have open systems that interfaces with some other systems, where we can integrate the system with some other systems as well. Okay, so we have a combination of these terms. So we have a system, we have a subsystem, and in the subsystem, there could be closed systems or there could be open systems. Open systems which can be integrated. Okay, like for example, whenever I report a taxation every year, I report to the tax to the government. That's a closed system. Nobody else can access that information except me, right? Because it's very particular to a person or to a certain individual. So this is an example of systems and subsystems. We have an accounting system. Whom do we owe? Accounting payrolls, general ledgers, account receivables, and report generators. These are all subsystems that we have in a general or bigger system. If you have questions, please feel free to ask. Okay. Now, why do people need information? Okay. So individuals, they can be entertainment and enlightenments. So that is why we need the systems, right? So we need to learn something, or we want to be entertained with certain things. For example, Facebook, communication purposes, YouTube for entertainment purposes. And then we have businesses, decision making and problem solving. Right? So businesses also need all this information. So we need to gather all the information about you and the other students as well, and then we will try to, we expect that you guys will come and join us one day here at JIC. So businesses, they gather information, they store the information, and then they manipulate the information. This third part is now these days, this is where we have the data warehouses. This is where we are coming across a data science field, and that's where the future lies. So if you guys are interested in IT, I was in Canada in 2018 at a conference. I was there for like 2 weeks, and I met people in I think it was a Microsoft organized seminar. So I was there, and what they think is by the year 2030, all banking jobs are gone. They will be automated. Okay? So that's where you can see that the future is all about IT. People will be replaced by computers. We cannot just totally eliminate people out of the system. No, there is a big debate which says, can people be replaced? So eventually, if everything is taken up by the systems, what will happen to the people? So what do you guys suggest? Can humans be replaced by machines and by systems? What do you think? Yes? Not really? Okay. Yes? It depends on the situation or where it is being used. Good answer. Yes, sir?
Yes, depends as well.
Depends, yes. Yes or no? Yes, okay. Yes, yes. So people will be replaced. I will be replaced as a teacher. You're threatening me, right? You're threatening me. Yes. I will be replaced. That's so sad. Yes. What do you think?
Can replace in some field.
Right, can be in some fields, yes. Not really, I like you, man. Yes, good answer. All right, so now keep that in mind. There are certain fields where people have been replaced, but new opportunities have come up, which has made people capable of achieving something more. And all of this has come up ever since the computer era has started. You know, things have gone way much better. If we go back 20, 25 years back, things were not as good as they were now. As they are now these days. So, you know, so things have really improved. You know, we've got internet. You leave your handphone, you feel like you don't have a hand. Right? So we are so much dependent on our handphones. We are so much dependent on our smart watches. And these systems, what they end up doing is they monitor our health. They enable us to live a healthy life, right? Because a couple of times when I'm sitting too much in my office, my watch tells me time to get up, go for a walk. Well, and there is this oxygen. You haven't taken a deep breath. Take deep breath. 20, 25 years back, nobody bothered. But where there are certain advantages, there are certain disadvantages as well. I remember when I was in your age, we used to go out and we used to play cricket. We found something for cricket. So we play cricket a lot outside. But these days, it's very outdoor activities have been limited. Right? So this is what I was talking about. So the businesses, they gather information, they store that information. Just like here in JIC, we will gather information about you, we will store the information. And then how do we manipulate? We will then evaluate the data that we have to see how many of you guys have actually joined us, for example. Okay? From there, we can manipulate and we can see how useful this EduFest program has been for the audience and for us as an organization. Banks also store the information, they gather the information, every transaction that we do, they store the information, then they manipulate. They see what is the trend, what is happening, how many people are saving, how many people are withdrawing. From there, they come up with different investment plans, certain saving plans. All of this manipulation has been automated as well. Automatically, there are trends. Right? A typical example is if you're browsing, you go to a certain website, for example, I go to Tokopedia to buy something, but I don't buy. As soon as I come to the newspaper and I watch some, and I look at some news, I'll see the advertisements on the side of Tokopedia, for example, showing me the products that I was searching. Now, those are known as small computer systems, which are known as bots. Just like the robots. These are bots, small programs that try to manipulate, look at the information that we do every day to see what are we more interested in, and that is what they present to us. And these bots, they work with these companies to convince, oh yes, I wanted to buy this thing. I go back to Tokopedia, I place an order. So it enables these e-commerce websites to actually interact with the real world as well. So that is what this has actually enabled us to do. And so many other things as well. For example, Google, it keeps track of wherever I go. Right? So if I'm late from JIC, I want to go back home. If I receive a message saying that, do you want me to schedule your trip back home? And I was like, who asked you to do that? But it's the automated systems. These are artificial intelligence systems that are built into our devices. And that is all known as artificial intelligence. So the future is artificial intelligence. Okay? So that's where we are heading to. So then as we are discussing about systems, so there are 5 important parts of any information system. They are people, procedures, hardware, software, and data. So that is 5 important components of any system, information system. These are the 5 important parts. So we have consumer support system. That's the overall system that we have, in which we have hardware, we have some inputs, we have people, we have data, procedures, software, and out. And out of these all 5 components of the system, the most important one is person, who is operating that particular system. You need an operator. Yes, some jobs will be replaced, but you still need a person who is going to look after the system, who is going to operate that system, who is going to manipulate the data in that system. So people are the most important part. Okay? So make technology works because they are the drivers that drives that computer system. So information system professionals and users who analyze organizational information needs, design and construct information system, write computer programs, operate the hardware, and maintain the software. So we still need people who are going to help us if there is any problem. Computer cannot fix itself. You know, computers are very dumb machines, but at the same time, they are very intelligent at the same time as well. Because we as human beings, we cannot multitask, right? So if you are here mentally in the class, then you are taking notes. If you are thinking about something else, you cannot take notes. Same is the case if you are listening to songs or you're typing, you cannot eat at that time. So we cannot do multitasking, but computers can. How? The speed of a computer so guys, the speed of any idea what is the speed of the processors? How is it measured?
By gigahertz.
By
Gigahertz.
gigahertz, yes, exactly, gigahertz. It's the pulses that comes in the computer system, and that's in gigahertz. Giga refers to, for example, you know what is the basic unit of computer system? What is bits and bytes? Yes, very good. What does bit stands for?
1 or 0.
1 or 0. Okay, that's what it is. But what does the word bit stands for? B-I-T. It stands for exactly what you said. Binary digit. So IT and B. That is what a bit stands for. Okay? Now, what is a bit? A binary digit. Binary means 2. That means it can be either a 0 or a 1. Okay? Can be either a 0 or 1. Now, in some computer systems, it means off, no current, and 1 means on, which is there is a current. So, how does the computer actually operates? In the past, we had analog system, which is like waves. But in a binary information system, the data moves in this form. So this will be 0, this will be 1, this will be 0, this is 1, 1, 0. That is how in our computer, in my mobile, this computer at the moment, everything at the back, what's happening is a combination of, this is not a car or a train, by the way. Okay, these are binary signals, which is going up or down. There is no other state. Like here, we have a 0 state, we have a 1 state, we have a 0.5 state. But in a binary, you can see it's either 0 or all the way it's up for 1, which means there is a current which stays there for this certain time. That's exactly what you said about hertz. So the signal will be for a certain time. And then we have a byte. A byte is how many bits? 8 bits. Very good. 8 bits. Now you can see both of these two words, they start with a B, right? Bits and bytes. That's why in order to differentiate them, if you see, for example, Mbps, that's the speed of our internet, right? What does that stand for?
Megabits per second.
Megabits. Excellent. Megabits per second. So it will be written as Mbps, small b. But if your internet connection is Mbps,
Megabytes per second.
megabytes per second. That's that's an amazing speed, and that's where we are heading towards. Okay? In 5G, that's where we are heading towards a megabytes. Instead of in 1 second, mega. Okay, so the smallest is a bit, then we have byte, which is equal to 8 bits, then we have kilobytes, which is 1024 bytes. Then we have megabytes, which is 1024 kilobytes. Then we have gigabytes, which is 1024 megabytes. Okay, so I'll just stop here. We have terabyte, we have zettabyte, and so on and so on. But at the moment, or let's say terabyte. Terabyte is 1024 gigabytes. Okay, so let's just talk about kilobytes because we said megabits per second. So how many bits are being transferred in 1 second? Or this is where we are. So that means 1024, it is kilobytes. So kilobytes, we can replace it with 1024 bytes. Replace the bytes with 8. So whatever your answer is, that is the number of bits that are being transferred in 1 second. Okay? So that is how the data is transferred in 1 second. Huge amount of data. Huge amount of, that's what the computers are, very fast machines. Now, another important aspect, I'll come back to this, even if we don't cover this, I think this information that I'm giving you is actually more useful for you guys. Why? Because you need to understand how does your computer actually works, or how does my mobile phone works. When I press an A, like I want to type, and you can see how quickly you guys type. You know, some students are amazing. If I catch them typing something in the class, they will go under the table and they're still typing. You guys are so good, right? So how does a computer understand our language? My language or our language is English, for example. It's a universal language. We all understand that language. But if I start speaking Urdu here, which is my mother language, would you understand? No, right? Would be very difficult. So if, let's say, you understand Indonesian language, I understand Urdu language, can we communicate? No, right? We cannot communicate. So same is the case with the computers. What does computers understand? Binary language. Computer does not understand anything apart from zeros and ones. Do we understand that? Is that what you type in? A lot of zeros and ones, a combinations of zeros and ones? No. So eventually what happens is, we need an interpreter, right? So we need, for example, Leona will be our interpreter. She understands Bahasa, she understands Urdu. So whatever I'm going to say, she's going to translate that to your language, and whatever you guys are going to say, she's going to translate that back to my language. What is the interpreter in our computers? Maybe the online students? Yes, sorry.
It's supposed to convert. Well, Junaid was
Check it.
Junaid was
I do know a lot of programming languages.
Not Java.
Java, yes.
And the better was convert into bytecode for Java.
Yeah.
And that's what
Who converts that into bytecode? Who converts in Java programming language? What is somebody is responsible, right? Who convert that? It's your compiler that is the one that is responsible to convert it into bytecode. But in our, now that's for a specific program. That's a very good example. That's the compiler is your interpreter. In our computers, who is the interpreter? It's our operating system. Okay? It's your operating system is the one that is your interpreter, which converts. For example, I'll just give you one instance. I know I've got another 15 minutes, but I hope this will be useful for you guys. So I'll just give you one instance, okay? And then from there, you guys can see the power of the computers. So, for example, we have, when we type A, right? And you can see sometimes our typing speed is like 60 words per minute. The good typists, their speed is really good. 50 to 60 words per minute. On an average, in 1 second, they can type one word. They are good typists, for example. Now, every word has got multiple characters, right? Hello, 5 characters. I'll just use one example. For example, when we type in A, does your computer understand A? No. What does your computer understand? Binary code. So who is responsible? We as human beings, we understand A alphabets and all that, but your computer does not understand that. So your operating system. So have you used a computer without an operating system? No, right? You buy a new system, from Mangalore, for example. You bring it home, there is no operating system. Is that machine useful for you? You can't do anything with that. Right? So you can't do anything with that because there is no operating system. Because that means your computer understands binary, you understand alphabets, you guys cannot communicate. Just like what I said here. I speak Urdu, you speak Bahasa in Malaysia. We cannot communicate because our languages are different. So we need an interpreter. And that interpreter, in most cases, is our operating system, which converts human understandable language into machine understandable language. So that's exactly what our friend was saying here about Java converting it into bytecodes. It's the compiler that converts a high-level language, Java language, into machine understandable language. And for that, programming languages, they use assembly language at the back, because assembly language is actually very close to the system. Right? We do teach assembly languages as well. We'll talk about that later. Okay. Now, this is the letter A. It's in hexadecimal. So the compiler, sorry, not the compiler, because I teach programming here, C++, I've taught Java as well, I've taught Visual, C#, I've taught many languages, Visual Basics as well. So the interpreter will convert this into, there are international codes, which is known as an ASCII code, American Standard Communication Information Interchange. Okay, there are ASCII codes, which have different alphabets, like on our laptops, you have all those keys. At the back, there is a certain code, a numeric, a number. So the code for A is 65 in the base of 10. Okay, a number 65, international standards, is assigned to a capital letter A. So if you type a letter small a, that has an ASCII code of 97. Okay, and same is the case. If you go to B, B is 66, and so on and so on. So that's how alphabets are. Then what the compiler will do is, the compiler will convert this into a binary number. So we have a bit, so this is one bit, a small piece. Like if you have, in the past, I don't know if you've seen CDs, right, the CDs. You see when you burn the CD, you will see certain area goes dark and certain area is not dark. Is because it is really burned. Burn means wherever it is, you put it under the microscope, you zoom it in, you can see certain areas are burned and certain areas are not burned. The burned ones are representing 1, the unburned areas represents 0. That's a binary information. So what the computer will do is, in a certain bit, it will either put a 0 or it will put a 1. Now, does not mean it really puts a circle of 0 or 1. No, either it's burned or it is unburned. Like this, if it is burned, there will be something like this. So it's burned, so this means this is 1. If it is not burned, it will be 0. Okay? So that's how computers will interact with us. Now, normally we said that there are 8 bytes. A byte consists of 8 bits. So there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of these. Because these are binary numbers, so they represent 2 to the power of 0, 3, 4, 5, 6, and 7. Okay, so in the binary numbers, we start from 0. We don't start from 1. We don't start with 1. So 2 to the power of 0 represents what? 1. So this represents 1. This represents 2. This would represent 4, 8, 16, 32, 64, 128. Okay, so don't worry. I've taught this so many times, so I know this formation. Okay, so it's just the exponent, 2 to the power of 1, 2 to the power of 2, and so on. Now, remember, we need to represent 65 in a binary number. So, which bits here do I need to make as 1 that will add up to 65? Yes?
To the power of 6 and to the power of 0.
To the power of 0, right? How? 64 plus 1 will give us a total of 65. Exactly, very good. So in that case, this will be represented as, so when we press a letter A at the back, computer will go, the operating system will check. You have pressed A, what is the ASCII code? The ASCII code is 65. Okay, I need to make this thing understand what is being pressed here is, so it will convert this into 01000001. How much time did I take to explain this? Just 8 to you guys. 5 minutes. Speed of the computer and the processors is MIPS. Millions of instructions per MIPS per second. That is the speed of the computer. That is why I say computer. If somebody asks you, well, what is the difference between a calculator and a computer? Huge difference. Calculators are the same thing. That is what they use as well. But the basic difference is here. Millions of instructions per second. Like this sort of this just one instruction for my computer to convert A into a binary language and for the computer to understand exactly what has been pressed. A computer would have done millions of instructions in that 1 second. Okay, so that is the speed of the computers. Okay? So a lot of our data is being saved in our computers, and this is the whole process. So I'll quickly go through this now. We have got another like 6-7 minutes. So as we discussed, people are the most important components. I hope the students who are online can also see this. Can they see this on the screen? Okay. So people are the most important part of any information system, right? Because people are the ones who build it. People are the ones who maintain it. So make technology works, they write the programs, operate the hardwares, and then maintain that hardware. And eventually they are the most important stakeholder for any information system, right? Stakeholders are the ones that are involved in something. Like here in JIC, it's the owners are the stakeholders. We as staff are the stakeholders. You guys as the students are the stakeholders as well. So next comes the hardware. What is hardware? The computer and its peripheral equipments, which are the physical devices, RAM, hard disk, motherboard, and so on. Input, output, and storage devices, hardware also includes data communication equipments. By the way, have you seen the motherboard? Have you seen the RAM, the hard disk inside the computer? Yes.
Yeah.
Have, right? Yes, excellent, very good. Normally in my computer classes, when I teach, I just go into the IT room, I say, open up a computer for me, just like this one. I bring it into class and I show my students that, this is where the RAM is, this is how, and these are different cables. Those cables actually transmits the data. They are known as buses. Okay? Like some of your operating system, you might have heard, is it a 64-bit operating system or a 32-bit operating system? What does that mean? It means how many bits can transfer in one round, in one go. 32 bits. So if your system is 32 bits, 32 bits will go together. If it is 64 bits, all the 64 bits will go together. Okay, so 64 bits is more faster. So disk drives, keyboards, printers, and so on. 5 functions of the hardware: they accept inputs, process data, they store the information, they produce the output, and they are used for communication purposes, right? And then we have software. What is a software? It's another name for programs. So, if those of you who write programming languages, so you create programs, those programs are softwares. Here, when we teach C++, I teach C++ in our engineering and our IT program, we teach students how to create games. Okay, so our students actually create games, but not a graphical user interface, but that can easily be replicated. So my students' program can be put up in any graphical user interface, and the game will take the graphical interface form. but they develop the logic of the games. And that is actually the main idea, that is the main key point. So when you write programs in Java, in programming languages, any programming languages, they are your softwares, okay? Which are set of instructions. So what are softwares? These are just instructions. What we tell our computer to do. Like out of the word 8 into 65 into binary, it's an instruction. So computer cannot do things on its own. It will do what we tell it to do. So it cannot do things on its own. It cannot. Unless or until these are artificial intelligence systems. Which, how does artificial intelligence systems work? They learn. And they make it a part of their repository. Okay? They learn. For example, you play chess with the computer. So the computer will learn behind it, this is a good move. It's not in my information system. It will save that move in its information system. That is how information systems work. How to take data in, process it into information, and display information. How to store. Yes, question? I thought you had a couple of questions. The word software and programs are interchangeable. Procedures. These are rules for achieving optimal and secure operations in data processing. Procedures include priorities in dispensing software applications and security measures. Procedures, ways. Okay. So what are the ways? How are we going to deploy that software? Who will be our users? So all that information we need to store in an information system. And then comes data. Data is used to describe facts about something. Files for documents, worksheets, and databases. So these are certain types of data. So data are inputs that the system takes to produce the information. So basically what we give as an input to a system and what we get out from a system is actually information. So we have data. Once you process the data, that becomes information. Okay? That is information. Used to describe facts about something, inputs that help people to make decisions. So these are information. And again, information can also be a data. Okay? Information can also be a data. For example, like I said earlier about you playing game with a chess game with a computer. So the computer, the move that you've done, that's an information. It stores that in its repository. That's a data. Okay? So the data that we use to convert it into information, the information can be a data as well. So data versus information. Data is a given or fact, a number, a statement, or a picture, the raw materials in the production of information, and the information is a processed data. So what is the difference between data and information? Data is, information is a processed data, right? So when you process the data, it becomes information. Any questions, anybody? I think it's about time. So these are the characteristics of information. It has to be relevant, accurate, timeliness, economy, efficiency, reliable, and usable. So these are all the different characteristics. Again, I'll just quickly go through this slide. So the data manipulation is the raw data, time consumed to read. These raw data are difficult to understand. Like you have lots of zeros and ones, difficult to understand. But once you process those zeros and ones into meaningful information, it becomes information for us. Manipulated data provides us with useful information. And then comes the information management system, managing the process of information and knowledge management, assist organization in achieving their goals, and so on. So that is how we make the information management system. Okay, I think it's about time now. That's it. Yes. Okay, so like this is what I was saying earlier. So you have input as the data, process is through the system, and output is your information. The framework for problem solving and decision making, that is what systems tend to do. Managers focus on overall goals and operations of businesses. Okay, so if you have managers, the IT people who manage that all of the process, they are the managers as well. So you have information math, you have information technology that facilitates the construction and maintenance of information system. And how is the data transformed or into information? You have input, processing of that data, output, and then finally that data is stored. So we have input devices, we have processors, outputs, and storage devices. And this is just a broad example of what they are. Thank you very much, guys. God bless you all. Thank you for taking your time here with us. And I really hope to see you guys in JIC somewhere in the future. Okay? Thank you very much. God bless you all. Take care, guys. Thank you. Thank you.
Thank you so much for coming.